the constant K and the Gaussian temporal evolution for COVID-19. My name is Balloni. This paper was submitted for the Congress appreciation 14 April and was accepted for publication in this Congress in the iLSET and also for publication in the iJournalist journal. This is our team, myself, Balloni. Rogério Winters is a PhD student at the University of Campinas, and a physician, Rogério Winters is an engineering, and a physician, Dr. Fabio Miranda Pisani. I am a physicist, if you want to know. Well, I'm going to tell this presentation has introduction, a constant K, or previsions, or conclusion, and final considerations. The research impact from this paper, it was already published in the, will be published in the iJournalist journal, which has this indexation, also published in the proceedings from this Congress, which has these indexations, and also is published a standard abstract in the colloquial ICEE, for what is already published with the permission from this from the iLSET Congress. Okay, so this is why the research, the impact from the ResearchGate. ResearchGate, you know, has more than 130 million publications, more than 70 million research. So our paper, this paper I'm presenting here, received about more than 100 recommendations, which means 96% higher from our research publications in the ResearchGate. And also for the year 2020, this recommendation means 99% higher for the publication in 2020. The same for the proceedings, 30 recommendations, 8% higher and 99% for publicity in 2020. Source of information that I'm going to use here is John Hospital. In my paper, we do not present any figure. So here I'm going to show you how we calculate the constant K. That is important. This is important. So before starting, as I mentioned in my paper, I have to come back in March 10. Okay, around the beginning of February, middle of February, I started to playing with the data from China, Brazil, Italy, and South Korea. And every day looking. When it came around 10 of March, I came to prevision that the constant K was 30 days, but playing. So I shared this to a lot of my friends, my fellows in professional fellows, from my friends from basketball group in WhatsApp, from high school, and start playing. So I continued to look every day, and I saw that you have that constant K was constant really. So up to 13th of April, I carried out a first TP analysis, and then I found 28 unique values of K, about 35 days, okay? And then in 19th of April, I carried out again another further analysis, and then 16 new values of K. And in 20th of April, the last day to send the publication already accepted, more 80 unique values of K. So you can see we analyzed 188 countries, and 52 present an experimental Gaussian distributed histogram, this by April 2020. I am showing this histogram how we concluded that that is right. Okay, the constant K. What is the constant? Word map inside the more representative curves. Okay, the constant K as in the paper is this distance. What is the constant K? The blue curve is an experimental Gaussian one. This is a real one. Everybody wants to see an experimental curve like the red one. Okay, that's not possible, at least for a while. So what is the constant K stands for? This is this distance from A to B, from minimal to maximum contamination. This is the constant for. So the average temporal constant and its standard deviation from 188 analysis, K is 35, more or less 5 days. So what is the constant K for? Constant K is a prediction tool. If you are here and you know, as Brazil knew, that you are going to have a peak in around here, 35 days later, so you have a lot of time to make strategic decision if you have a public policy. Let's continue so. Here is the validation of the temporal average of constant K. This figure should be enough to close to end my presentation right now. This figure I published in 22 of June, more than 2 months after our conclusion. But they are showing this to the American public and to whom it may concern, that the European country, look, European Union made their homework and they are in a very comfortable situation today. And United States, it is like this, start increasing, decrease, and now it's going up indefinitely, okay? Let's say European Union has 51 countries. In our paper, we have used 29 countries. So our curve is inside here. But what they didn't say, and it was not the intention, was about the constant K. The constant K for maximum to minimum for USA, green cover, is the same for the European Union. Look, you can see here. So that is very, very good validation for our results. What came, fortunately, more than 2 months after my publication, our publication. So we have I am presenting for you the continents where we have the constant K. Oceania, European, America, Oceania, Africa, and Asia. Each one is the number of countries, total 52. Today in this presentation, we have more than 52. Indeed, we have 53 and much more because now we understood how is the process of the peak contamination, okay? Is this the value of K? If you get the average this, you get 35 more or less 5 days for the constant K for the 52 country, okay? So let's continue. Okay, this is the K distribution, the range of K distribution, okay? You can see from 26 to 30, 23% to 30 per 35, 23%, 35 to 40, let's say 40%, 39, 40 to 44, let's say 12%, and 44 to 48, let's say 2%. And the distribution is centered in 37 days. I'm showing this you because I want to show you the word, the constant K for the word. Don't see here's the 37 day. Most of the data is centered around 37 days, but when you take the average, considering this data outside and out, you get the average 35 more or less 5 days for the constant K, okay? But here nice because you have the index K and the value of K. So if you want to know the value of K in this figure, you go in that one if you know the value of K. What you have here, you can see here the peak contamination for each value of K in the index. You can see the constant K is shifting, is dancing from one side to the other. And this, okay, it makes us to understand the reason the constant K for the word is larger than for the constant K for the each individual country, okay? Constant K for the word I'm going to show you is 47 and 35 is for each country. We can now summarize like that. So you can see here what you have here. The very nice Gaussian curve for the word starting to decrease. This is April 20. We waited last day before submission. But you have to find a starting point for the word because China is not a Gaussian distribution. So this point around here is around here. And a huge contribution. Then we subtract and find the real 0.0 for the word is February 25. So from February 25 up to the peak, 47 days, more or less half a day. Half a day is a half of each one of these. This means 1 day. Okay, so we have in this. We look at the total curve up to June 2. Okay, what you have here? Then again, you can see the very nice distribution. Should you do like this? Look, should do like this, and then exploding. Okay, what is the red curve? Red curve is Brazil after. The beginning of 23 of April, Brazil make a symptomatic behavior, not Gaussian anymore. Should be Gaussian, should be like this, like a lot of countries. So we subtract here the data from Brazil. You can continue this up to today. And they also subtract here the 11 other countries, I will show you in the next slides, the contribution because they are also not Gaussian profile in the right side of the curve. Okay, so you can see now with the subtracting the curve start a Gaussian one, very nice, and then decreasing a little bit more than is here because I draw it by myself. Is okay. Okay. So the conclusion here is since the curve of the world has a Gaussian profile, at least from A to B, from the minimum to the maximum, then the Dalton's curves must be Gaussian. Okay. And the word constant is for the word constant is larger than the constant for individual country. Let's see. So this is an important graphic too. We have here 11 countries, including Brazil, that has this kind of profile. Can you follow me? Please look. The Gaussian profile, 11 countries I will show for you, and then and then start to decrease like US, and then Brazil spike, okay? Asymptotical behavior, not a Gaussian anymore. You can find something around here, explain later. From A to B, this holds, this value for the constant K, this value for the constant K for these 11 countries is working. We have 30 countries that do this kind of behavior. Look, do starting very nicely, and then start to decrease, and then spike, down, spike, down, and then decrease. This also, constant K also hold here, 35 days. And to also here, I will show for you that also works here with a slight variation. And also we have 12 countries like this in European country, very nicely curved, very well behaved curve, like it is. We see not significant new spike during the decreasing process, okay? In one country, it has a mix of both. Do like this, start and do it like this, and decrease, and then spike like this one. Okay, it's one country here. So, okay, let's continue. Here is a representative curve for America, Chile. You can see the start very well, nice curve, 35 days. Now I will put out the average value for constant K, 35 days. And here we have the up to June 3. If you look at the full curve, you cannot, never you would see the spike here, the peak here, never. You will not get any conclusion because I follow day by day since the beginning of February. So you can see the here asymptotic behavior for Chile. Okay, but the peak is here. Here, for Brazil, that we knew, we should take the public policy actions, and okay, I will say take this part later. This is the Netherlands curve. This Netherlands curve is not in the paper because you are unsure about the width of this curve. But after we understood what was going on, then the constant K is also 35 days for Netherlands. It's the 50 days as we have other countries too. This is the Netherlands. This Netherlands full curve, okay, and very nice one. If you have several spike, you can 35 days here from minimum to maximum. You can see to get to the minimal point, not zero. Minimal point is very dangerous. This minimal point, you will have more or less 35 days. 35 more or less 5 days. Okay. This is Thailand, very nice curve. Also, this is experimental Gaussian. Okay. So you want to see the red curve when I explained in the beginning. Forget it, that is now. This is the New Zealand also from minimum to maximum 35 days, day of collection 13th of April. This is Morocco. Morocco, I was to look at make the decision to consider 35 days. Look at the final curve for Morocco. It's very nice. It could be like this one, like could be like this, okay? So the constant K also here from A to B, from minimum to max is working. And also Brazil. Brazil is starting a slight discussion right now. 35 days. We take a lot to make the decision to put Brazil in this publication, but it is here now. 35 days with singularities like counters. And here the full curve from Brazil. If you look at the full curve, you never would get to conclusion that here in 15th of April, more or less, 30 days before, we should have taking action 4 days before. Instead, we did on contrary. Decontamination was nothing. So we have this, can you see here, up to June 3. I will back to this subject later. Our previsions. The prevision is you may affirm for those countries following an experimental Gaussian profile, the decrease from contamination should have the tendency, should trend, have the tendency to zero among minimum 30 days or maximum 40 days after the peak contamination. Trend to zero, okay? Not real zero. Okay. These assumptions are correlated directly with the public policy adopted by each country regarding the role for quarantine, social distance, using protection, washing hands, and so on. If you do all this, the curve from Brazil, at least, and maybe the other countries, never would get a peak. It should be, I will show you later, should be something different. What would be very good. And finally, this is the real zero contamination. Takes a while to go to null. If no prep care, no proper care, such as I mentioned, so against this increase in social distance during the time, protection, the contamination started to spread all over again, as we have seen. It's so easy, we have media to help this, but now the problem, the issue is already caused. So let's go to the next. The conclusion. The conclusion. Our conclusion is the methodology presented here for minimum to maximum is a simple, straightforward method applied to a histogram with a Gaussian tendency for calculating the spread of COVID-19 contamination, the constant K. Okay. The average value K is 35 more or less 5 days, and we get to it after analyzing 108 countries. 52 present an experimental histogram. So K is a prediction tool. The constant K is a prediction tool, which offers a reasonable methodology to easily detect what is ongoing with the temporal spread of COVID-19. The maximum range for the contamination will occur up to 40 days, and from the first register contamination, and in the worst scenario, 30 days. The worst scenario, 30 days means too much people sick in a short period of time. Perspective. Perspective, I would like to read this for you. Regarding the new peak or wave, it's similar when you have seen in the media new peak, new wave. It's similar when you throw a stone in a lake. You have a wave. 10 minutes later, you throw another stone in the lake. The result will be the collision among waves, creating destructive or constructive interference. For coronavirus, the new wave or peak is similar to throw a stone in the contamination rate and generate constructive collision. This stone is represented here by the lack of a public policy on the pandemic issue, which increased the rate of contamination by breaking the natural tendency of contamination rate. This is, we mean, artificial or inflated expansion of the virus contamination. Which, if you had done on contrary, we had flattened the contamination rate. Okay. Okay. Finally, for a curve with no Gaussian profile, the point of minimum contamination should start counting after the last peak. I told you about Brazil. Brazil has symptomatic behavior. If you are sure that in the end of the symptomatic behavior start to decrease in a constant way, you can consider that peak after the asymptotic behavior and count 40 days is where you are going to have the minimum. But this is not important information, the minimum. The important information is what we are going to do when we get to the minimum, okay? So we are back in this prevision. Let's see the next slide. Final consideration. This is South Korea. I have mentioned a lot in my paper. We see the 35 days, this is the constant K, maximum. Here, the example I told for you. Here is 35 days after the March 3. You can see you get to a minimum. Less 5 days, more 5 days, okay? You can see what happened to South Korea, very civilized country, very everything good, at least in some aspects. And so they have a second wave here. Look, a small second wave because the tiny, South Korea is a tiny country with a tiny population. No, it's not like Brazil or USA. Okay, anyway, let's see. Turkey. Again, Turkey is very nice Gaussian profile. These are getting, here is the full curve for the distribution. You can see, again, from the peak 11 April, but 40 days, 35 days, you get here. Look, we have stabilized around the time for minimum contamination. Ah, okay, good, we are safe. No, no, we are not safe. Now we start the problem, okay? Let's continue here. We have Luxembourg, the same aspect we have explained. May I continue? Hello? Okay, the same, here is 35 days after March 26, okay, minimum, and again, a spike again here. We have to be careful, okay? Again, Tunisia, okay, the same, the point of maximum contamination is, here is 35 days. If you put 40 days, we're here, look, minimum contamination, then minimum spike. Hello? And here is Australia. Australia, the peak of contamination, and the curve here is 35 days for minimum to maximum. And here again, March 7, 2020. And here what happens to Australia? A real wave here. Careful. I don't know what we're going to do with this virus. We could have minimizing this if we follow the constant K in the beginning. France is the same. France did a very nice job and homework, okay? And here is Brazil. Brazil is difficult to conclude something. We have a spike here in 19 June. We have a new spike here. If you look at the minimums, this hollow here, this empty place here, you can see apparently we have a trend to grow and maybe, I hope, start to decrease. When it starts to decrease, you can take somewhere around here, and count 40 days for the minimum contamination for Brazil. Well, I hope I did enough. This is the reference I have used. And also, I hope you have understood my presentation. Thank you very much for being with me. Thank you all. Now I'm ready for a question and answer. What you like to do? If you are talking, I'm not here.
Oh, no, nobody asked yet. But I was going to ask, have you looked at the US? Oh, go ahead.
I have a question, please.
Thank you, Balloni. I have a question regarding, did you see the peak and thereafter again it's another peak, and sometimes it's increasing. So my concern is, while you addressed in many plots the constant K value, and still your mini plot is going up in United States.
Could you say again, please? I cannot. Could you say again, please?
Yeah, sure. So most of the plot histogram that you showed us, and it's showing the peak, but most of the plot they are showing they are going down, but again they are going peak. They are going on the peak, and it is not sure whether they will cross the previous peak or they will stay with the previous peak. So it's not sure. And you showed about 35 plus days. And does it make like the sense for the all country, like the generalized calculation, or do you want to say this prediction after 35 plus 5 days is a uniform for throughout the all countries, or only few countries or few states? What is your conclusion?
Okay, the conclusion is the following. The constant K is for any country which has a Gaussian profile. Look, like this one. Look, like this one. Look, like this one. This is a European country. Look, very nice Gaussian profile. From here to here, 35 days. From here to here, 35 days. From here to here, 25 days. What we have in the right side of the Gaussian for Brazil, in the US, and other countries, start to decrease and then asymptotical behavior. What you have, we have this, at least in your paper, 11 countries, including Brazil, with this kind of behavior here. Here, what we have here, very nice Gaussian distribution increasing, and then it start to decrease and then spike, start to decrease and then spike. For their left side, the constant K is working. Also, in spite of you have this spike here, for this 30 country, the constant K also holds for the right side. A little bit less, but holds, okay? But coming back to this point where we have the maximum and start to decrease, and then asymptotical behavior. Let's do let's imagine that you get to the maximum of this asymptotical behavior, and then start to decrease. I am affirming that from this maximum up to the minimum point stabilized, you have also can use also apply 4 to 5 days. This is what I explained as I'm betting on this. Here, I am sure, in spite of have spiking or peaks, the Gaussian goes down. And here, from this point here, up to the minimum contamination, not zero, minimum, you can apply 40 days. But this right side does mean nothing, 40 days. The important is you know, after 40 days from here to 40 days to the minimum, what you are going to do in terms of public policy. Because if you know you relax, the contamination start to spread all over again. The important point is from here, minimum contamination, first contamination to the maximum. Because you know it takes 35 more or less 5 days. So here, if you take the proper actions as public policy, you can stop this to increase, or you can do this flattening, and you save lives. I don't know if I answered your question, but here, this is a Gaussian profile drawn by CNN. It corresponds to 29 countries. For our publication, which has 52 countries, 29 countries is in our paper. It has a Gaussian profile, as I have explained for you, from here to here, and other countries from here to here too.
So in
We have a
conclusion,
question too.
go ahead, please.
Well, this is just from the chat. Someone asked, when you said the constant K has a value of 35 days maximum contamination period, does that mean that is the period when expect a normalized distribution? And what is the implication of this constant with respect to R value and the spread of COVID-19 on a contagious global scale?
Okay.
I guess maybe they're asking if the 35 days is
I will back this slide here from Brazil.
Yes.
This slide, look, here, April 20. We have the peak here. We have predicted this. You cannot see now because the scale is very high. But you put this, you amplify this, you can see.
Yeah.
Oh gosh. Sorry. You can see the peak. If here we have taken the proper action, the Brazilian curve instead to do the peak, could do a little bit more. Here or in May, could do a little bit more, and then start to do this. Look from this drawing I'm doing here up. All these people are contaminating, and with the perspective to increase contamination. It is clear, it's evident. We have 52 countries showing the constant case 35 more or less 5. So if in the beginning, around the April 20, if you adopt a public policy, you use the media, say, stay working, keep the social distance, wash your hands, use protection on the face. I'm sure the contamination rate will decrease violently. It's difficult to hypnotize people, but sometimes they get this hypnosis on people. So, intensive marketing. But now it's too late. Maybe in another COVID X, we can apply this method and see what's going on and ask for protection. Instead, you are waiting, it's nothing. We are here in Brazil and some other countries too. Even with our protection, as I mentioned for you, you can see at the end there, it's not Brazil, but let's say the contamination is here, very flat after the peak, and then you have a new wave, okay, but not so significant as was in the first peak of contamination. I didn't know, okay, was myself clear?
We have the most infections of any country in the United States, and it's getting much worse. It's just, we just passed over 300,000 in Florida alone, and people here do not wear masks. A lot of people think that you shouldn't wear a mask, and people are convinced it's a scam or it's made up, that coronavirus is not even a real threat. It's just unbelievable. Good luck with public policy in the U.S.
You have CNN, Fox News, others media much more stronger than we have in Brazil. If they take into consideration that the coronavirus is dangerous, everything should be different in the U.S., should be different in Brazil, and so on.
Oh yeah, if you just had President Trump, if he were to come out and say that, oh, you need to wear a mask, like it would save thousands of lives, because so many, like we got like, you know, I don't know, 40 million Americans believe that you shouldn't wear a mask. It's just, it's unbelievable. It's such a waste of lives. And
same in Brazil.
And unfortunately, Trump is, let's say, a world leader. For someone, not for me, but for someone, yeah, what he says is allowed. Gosh, you know, what happened in Brazil? Same.
Mm-hmm.
What do you think it's gonna happen in Brazil? Like the cases should going up, or how many days you think it's gonna go down again?
This is a good question. I have done this question for myself. A lot of friends have done this question for me. I would say, if I were here, I could say what to do. Now, my dear, now, shut down. I do not know how we are going to predict who from this is where. Who from here, which contaminated person is where. Who from here is where. Where you have been, you have carried out the contamination, have spread the contamination. Very difficult now. Maybe only God knows.
Contact tracing. And, you know, we couldn't even do contact tracing, you know, in the US back when the curve was smaller, but now it's impossible to do contact tracing, and there's no real program to do it.
Exactly. European countries did this. They trace. It's easy. Even for Brazil, it would be easy if you were here. We talked about this. We have tracing here. Look, here, but tracing here. You have no way. Even in the United States, maybe United States could have. I don't know. I believe it could have.
I believe so too. But now is too late. There's no way to do it at this point. We have 3.5 million infections confirmed, and how many more now that, you know, haven't been tested?
My gosh. Yes.
Now we hope for a vaccine. Now we hope.
Thank you, Carolina. Yeah. Hopefully, but then when a vaccine comes, it's going to be a long time before we have enough to distribute. And here we're going to have a lot of people who will say they're not going to take it. It's like, I don't know about Brazil, but there's a very big counter science, you know, people against science, against medicine, against evidence.
These people who is speaking now, these people has the voice of the media. If you, if me, would have the voice of the media, we could impact our opinion. But I don't know, the fourth power, okay? Media.
Yes.
What are the other countries among the 11 asymptotical countries? You mentioned the USA, Brazil, they are both big countries. And are other countries also big or not?
I'm not sure if I understood, but from the 52 curves, I have showed for you, 11 presented asymptotical behavior after 20 of people.
What are the countries?
Oh my gosh! You have to look at the paper. You have to look at the paper. You are going to find it. You have to look at the paper. It's not secret, okay? You have to look at the paper. I do not remember now to say for you. Brazil is one of them. Maybe I do not know. I have to say countries that is published, countries that show this behavior, but is not considered for publication Okay, maybe it should be considered because now we know from minimal contamination after the peak. We know after the peak. So if we start the peak and immediately start the asymptotic behavior, we have not considered because we are not understanding. But now we are understanding. I suppose you too.
And you could treat New York, Florida, you know, California as countries to see what they look like. Yeah, as individual states, but you know, put them in there like you know, then you'd see sometimes like California has so many people and we have 22 million people in Florida. I believe we have like the highest rate of infection in the world, possibly.
But dear listeners, you see California, see now the disease is in the interior of the USA. Someone for New York, someone for California, someone for Florida came or went to to the interior. So they carry the contamination. And also, yes, it's very, very difficult to.
Yeah, there were people thinking at first, well, it does not affect rural areas. I mean, these people who were saying that were not real, you know, epidemiologists or scientists. But of course, that was disproven 100% to see it spreading through rural areas, through, you know, not densely populated. I don't know what we're going to do here. It's just a terrible thing. You know, I look to the future as, are we going to catch it? We're trying to avoid it, but then how can you when it's everywhere, you know? And having I have a son, he's 17 months old. Some children even suffer very badly. And you don't know how long it could be for them to recover and what the long-term effects are because it's a new virus. So they don't know, let's say people recovered. Well, what are they going to face later? We don't know.
Yes, exactly. Also, this is a comment, okay? I'm afraid to do this comment, okay? They are talking about vaccine. Vaccine, you cannot develop a vaccine in the frame of 1 year. It's very dangerous. You do not know the correlation in a system with this, what is the integrated system, there is a word for that, is, oh gosh, okay, it is very dangerous, you know, systemic way. You can, vaccine will interact in a systemic way for everyone. So it's, when you have to take time to develop a vaccine.
It's never been done before to develop one that quickly, and they're going to have to do. I think they're already doing the live trials instead of like doing it in a dangerous way to try to get one quicker. But you know, there's a lot of side effects.
You mentioned you do a live trial, and then you have to take this person and put him in the jail because he can carry a new virus, a mutant, a strong. It's possible. It's not a war here, but it's possible. You cannot give the vaccine to someone. Okay, you can go now. At least a quarantine for this guy. Examine him every day, every hour, to see what's happening with his biology. It's in my opinion, okay? I'm not sure I'm right or I'm not right. It's my opinion. Media should help. Media should help.
Yeah, I agree. They're doing the opposite. They're hurting here. You know, the media has been so bad, and the leader of our country is putting out propaganda that it just doesn't work against a virus. To say there isn't a problem and, oh, go about your normal, you know, business, and it's a humanitarian tragedy that is going to just get worse and worse. We've lost 136,000 people. And you know, the curve is going like this right now. I would like to see, we have Brazil for up to July 14th, but if you look at the USA, I think it looks even worse.
We had hope that here, look, please. We have to here, we were here. Look, decreasing, oh gosh, we start decreasing, and then a jump again. Oh my gosh.
Yeah, when you have the chart though, are there any effects where fewer people are tested on a particular day, or the test results come back all at once? Because what we've seen in Florida is it's still hard to get a test, and when you get tested, it could take like a week for the results to come back. And so on some days it'll be, oh, we only gave 20,000 tests, and another day there were 60,000 test results came in.
Yeah. And if he is contaminated, 1 week later, where he have been?
Oh yeah, yeah. And I
Very
was thinking they're gonna have. They said we'll have the instant test. You know, take it, tell you right away. I'm still hearing from lots of people that, oh, I got a test. They don't have the results yet. They're mailing it to Arizona. It's like, why Arizona? That's 2,000 miles away. You know, to not be able to get the results quickly is a very big problem.
I see. Very
Oh,
nice.
and here's somebody, Heather said, a report from Reuters saying that the Moderna phase 1 results induced immune results, provoked immune responses in all healthy volunteers, 45 of them. I believe that was actually something that made the stock market go up even higher yesterday, because it was a favorable result for a vaccination trial. But sometimes these vaccine trials, they kind of, I don't know, put them out and you don't know yet for sure whether they have released, you know, all of the data to let you determine it on your own. Because the companies are private companies, and it like, oh, their stock goes up because they put out a press release that the vaccine is going well, but they don't put out enough information to actually examine to independently verify what they're claiming. But we will see, we will see.
Yeah, we have to wait. Meanwhile, have to use all protection. For example, also, if you go outdoors, you have to use protection. And when you come indoor, you have to wash your hands. Okay, everybody knows this, okay? Allow me, please. You have to wash your hand and exchange your clothes. This cloth, I was outdoor, should be left outside the house. Think about it. And then get another one that's clean, maybe dirty, but not it went outside the house, and use it inside the house. Use it inside the house. We are adopting this procedure here in my family, but my family is a unit, you know, a unit.
Mm-hmm.
This must be a collective behavior.
Yeah, yeah. The mask, people here will not wear masks. I mean, there's people refuse, they don't wear the mask correctly, so their nose is hanging out. It's a disaster. I mean, we can't get people to, there's people protest here just yesterday that they won't wear a mask because it's tyranny. It's like, these people are nuts. It doesn't make any sense how people behave in Florida. I cannot understand.
They are, I don't know if I'm speaking correctly, hypnotized.
Yeah. I guess we will, for today, the agenda is just pretty short, and it is only my presentation, and Dr. Bradley could not make it. So I'll leave it up to Dr. Sahin what you'd like to do at this time. And tomorrow we start at 10. I'll probably come to that. I'm sorry that came kind of late today, and thank you for bearing with me. We have in the morning, Professor Dr. Shang and Dr. Jakowitz for the 10 a.m. to 11 session 1, and that's got 4 papers. And then tomorrow is an all day through 4 p.m. I believe, or 3. Yeah, it continues until 4 p.m. I think, Eastern time. Good. Yeah, so I think we're doing it in such a way that in a normal conference you go like to different rooms, but now we don't have as many people on this conference, so everyone will get to see everything if they want, instead of having, you know, we won't have 2 things going on at once per se.
So later, when you edit, could you share this presentation with you only in this moment? Okay, only with my presentation. Could you
Yes, I think Ismail, are you recording? I believe you are the host on Zoom. So after he ends the meeting, it will export a video, and then it'll be a 2-hour long video that you could upload to YouTube. You could put it as unlisted on YouTube or something, so it's not public if we don't want it to be public. And we could also edit it to cut it to make it, divide into two segments.
Yes, sure.
Okay.
We will do it.
Excellent.
Yeah, very good. If you share with me, I don't know if you are here, my internet is unstable. If you share, when you share with me, I will make it public also. But I would like, please, if only my presentation, okay, from the beginning up to now, up to this moment, up to we'll close here.
Oh, yeah, we can do that. In fact, even without knowing how to edit a video, it's possible on YouTube to use the feature on there to splice it. So that's excellent. And we appreciate you coming, and all of you for being here. I know that it's a little bit different. I like the future as being internet like this, because when you look at international conference, it's so much carbon emission, flying. Sometimes we have people here fly to Orlando from South Africa, and they're here for 2 days and then they fly right back. And it's just not going to work, for our future when it comes to greenhouse gas emission, not to mention coronavirus.
Yeah. Yes, that's true. Yeah, well, I do not hope, okay? I do not hope when we have a COVID-X, we should apply this methodology, or apply this methodology to the previous virus contaminations to see what you had there. So you look at the past, you look at the present, you can see the future, more or less.
Yeah, I think it's a good idea, and it's probably something that they should, people have. I want to also mention the human psychology is that right now in Florida, for example, this is the most dangerous time of all, because we just are hitting huge new numbers of cases, but people are a lot of them have financial issue too, where they're out of money, but also they're getting tired of quarantine, or they're getting tired of worrying, so they let their guard down precisely at the wrong time. Actually, objectively, it was safer in April, it was safer in March, it was safer in June even. But now you got people, congregating for July 4th and going to the beach, all with their, friends. They're at house parties for graduation, birthday parties. And, we had reopened bars, and the bars that reopened, one person went in, everybody got coronavirus. It happened here, right around our area, many parts of the state. But nobody learns. Nobody, learns a lesson. It's just we're doomed to repeat history over and over.
Yes.
Oh, hi, Heather. Yes. Yeah, I remember it's so expensive, to travel and have to get a hotel, and that's on top of the conference fees and the, Uber and airlines. Yeah, I think that there are some people they call concerned scientists about climate change, that if they have a face-to-face conference, they say the way to do it is to have regional conferences instead of international and national ones, where people from that area come together, and maybe some other people, also attend remotely. We have a lower amount of stipends when it comes to graduate students, and the same for tenure track professors. They are not offered as much money to go to conferences, to pay for their travel at University of Central Florida. They're not offered as much money as they used to be as a travel stipend. So it's getting harder for them to, and now of course everything is changed with coronavirus. I think we will have proceedings as well later, so I will help with that probably more after November 3rd. We'll see. There's a chance I could be going to Congress. So far we've been doing pretty good with our campaign here in Daytona Beach area. I guess we should wrap up. What do you think, Dr. Sain.
Congratulations.
Thanks, Richard, for your great presentation, Dr. Balloni. If Dr.
Thank you,
Balloni
Dr.
has invited his colleagues for his presentation at noon, at 12 p.m.,
Oh,
he
right.
can presentation for them. It's fine with us.
Yeah, sorry about Dr. Bradley. I didn't know he was canceled. But do you want your colleagues to come on now? If they want, they could join it now. The Zoom link is in the program handbook. Let's see. Yeah. If you send this link to your colleagues, if they want to come and talk about the research, it's up to you, Dr. Balloni. Did you hear back from your co-authors?
I'm not sure I followed what is going on. You
well, originally,
to share the
did you?
presentation?
No, I mean, when you came on, we had Dr. Bradley cancel and we had you go an hour earlier. But you may have had some co-authors, colleagues of yours. Did they want to talk about?
I don't know if maybe let me see if they are here.
Yes.
Let me see. He had planned to be here, but they will be here later. You have two colleagues here, but I think they do not want to do questions, I believe.
Okay. We have one person who says iPhone, and Dr. Ali, and then we have, we have a total of 16 people. If you go through the list, it should show.
But no, there is no problem because we start 1 hour soon. Once I have the video, once I have this record, so I can share and say to them to watch there. Because
okay. We were just wondering if they wanted.
Procedure, okay.
We were just wondering if they needed to talk, to tell us anything, if they wanted to.
Yes, I see. Yes, it would be a pleasure, but they are not here at this moment.
Okay, well, here, but yeah, I think maybe then, do you want to adjourn for the day, Ismail, and then for Dr. Bradley, we can have his keynote go at the end on Friday or yeah, something like that.
Okay, good. Well, so we get to the end.
Yeah, I have the schedule. So we're seeing here that Thursday starts at 10 a.m. Or I'll say in 24-hour clock, 10 o'clock Eastern, and then ends at 15:45, which is 3:45 p.m. tomorrow. And then on Friday, the schedule is 10 to 4:30 p.m. or 16:30. So yeah, we'll find a time for Dr. Bradley. And the schedule has a 15-minute break in between each session, so that gives us some flexibility. Well, thank you all for being here, and feel free to reach out to me anytime. I'll put my email in the chat, and I'll look forward. I'll come on to probably at least half of them, maybe a little more of the sessions, and look forward to looking at your research and hearing it. Thank you, Heather from West Virginia.
Thanks everybody.
Very good. I think you have more questions, please. No more. So I'd like to thank you, Dr. Richard, and also Dr. Sahin for this opportunity, and to everybody who is watching this presentation. As soon as I have it, I will share.
Okay, excellent.
Have a nice one to everybody. Have a nice one.
Yes, you too. I'll see you later, Dr. Balloni, and thank you for your research. I'll keep up the good work, everybody.
Thank you very much for your questioning.